Dear students, welcome to the problem solving session part 3 on Laplace transform. In the first video, we see the definition of Laplace transform and basic formulas. And the second video, we solve simple problems on Laplace transform using trigonometric identities and linear property. And the part 2 video, we solve problems using first shifting theorem. How to find the Laplace of e power at into f of t. Similarly, Laplace of e power minus at into f of t. In today's session, we are going to see the concept of differentiation of a transform or multiplication by t power n. So if L of f of t is going to be capital F of s, then if I multiply t power n with f of t, then how to tackle these kind of problems. That is what we are going to see in this session. So L of t power n into f of t is going to be minus 1 whole power n times differentiation of L of f of t with respect to s, that is minus 1 whole power n times differentiation of capital F of s with respect to s. Now most of our problem we might be getting t into f of t or maximum t square into f of t. So if L of t into f of t is going to be minus d by ds of L of f of t, that we can say this as minus d by ds of capital F of s. Both are correct. If it is t square, the minus 1 disappear because we have minus 1 whole square. So d square by ds square of capital F of s. Now let us go into some simple problems which make you more confident. Before that, just recall all the basic formulas which you are going to use in problem solving session. Find the Laplace transform of t into sine 3t. So we have to apply differentiation of the transform. L of t into f of t is minus 1 d by ds of L of f of t. That is L of t into sine 3t is going to be minus 1 d by ds of L of sine 3t. We know that L of sine 3t is going to be 3 by s square plus 3 square, that is 9. Now we have to differentiate this 3 by s square plus 9. We have to follow the u by v rule. v du minus u dv divided by v square. I am writing all these formulas because there are many non-max students who are there in the group. So now this is going to be my u and denominator is my v. Now differentiating 3 by s square plus 9, we have one minus outside. So denominator is going to be s square plus 9 whole square. This is v square. Then v du, s square plus 9, differentiation of 3 is 0 minus 3 into differentiation of s square plus 9 is 2s. Simplifying this, we get minus 6s divided by s square plus 9 whole square. Now minus into minus plus, so we get 6s divided by s square plus 9 whole square. Next, in the similar way, we are going to solve a problem t into cos 2t. So apply the formula. Differentiation of the transform L of t into f of t is going to be minus 1 into d by ds of L of f of t. Now L of t into cos 2t is going to be minus d by ds of Laplace transform of cos 2t. Now minus d by ds of s by s square plus 2 square, because we know that L of cos 2t is s by s square plus 2 square. Now differentiating this, we get minus of s square plus 4 whole square v du s square plus 4. Differentiating s, we get 1 minus s into differentiation of s square plus 4 is 2s. Remember, we use u by v rule. My u is s and v is s square plus 4. Now simplifying this, we get s square plus 4 minus 2s square. Denominator we just keep as it is, s square plus 4 whole square. Now we have minus s square plus 4 divided by s square plus 4 whole square. Multiply the minus inside, we get the final solution s square minus 4 divided by s square plus 4 whole square. This is my answer. Next, we are going to the problem Laplace transform of t square into sin t. So if it is t, we have to differentiate once with respect to s. If it is t square, we have to do twice. So let us write the general formula for differentiation of transform. So L of t square sin t is going to be minus 1 whole square, it is going to be plus d square by ds square L of sin t. First let us find L of sin t. L of sin t is going to be 1 by s square plus 1. Now we have to differentiate this twice. Minus 1 whole square is 1. So d square by ds square 1 by s square plus 1. Next we have to differentiate 1 by s square plus 1 twice. I am going to take this as u by v. So let me differentiate once. So I'll keep 1 d by ds outside. Now differentiating this, we get denominator s square plus 1 whole square. In the numerator v du s square plus 1 into 0 minus 1 into s square plus 1 differentiation is 2s. So d by ds of minus 2s divided by s square plus 1 whole square. Next we have to differentiate this again. Now differentiating this using u by v rule, my denominator is s square plus 1 whole power 4 because it is already s square plus 1 whole square. So v du s square plus 1 whole square, differentiation of minus 2s is minus 2 minus 2s. Now I will keep this, and differentiation of s square plus 1 whole square is 2 into s square plus 1, and then differentiation of s square is 2s. Next we have to simplify this. We can see s square plus 1 is common. If I take s square plus 1 common, we get minus 2 s square plus 1 minus into minus plus 2 into 2 into 2 8 s square. Denominator we have s square plus 1 whole power 4. Now we can cancel this s square plus 1 with denominator, and then finally we get 8s square minus 2s square minus 2 divided by s square plus 1 whole cube. So it is going to be 6s square minus 2 divided by s square plus 1 whole cube. Now we'll go to the next problem. This problem has three datas: L of t into e power t into sin t. So we have to apply both first shifting theorem as well as differentiation of the transform. So just recall the first shifting theorem. Since we have e power t here, I am writing the positive result L of e power a t into f of t. And next, differentiation of the transform. Since we have t here, L of t into f of t is going to be minus 1 d by ds of L of f of t. Now, first we have to apply the first shifting theorem. So, we get L of t into sin t. S should be replaced by s minus 1 at the end. Next, we have to apply differentiation of the transform. L of t into sin t can be written as minus d by ds of L of sin t. S is replaced by s minus 1. Now we have to differentiate this. For this we need L of sin t. L of sin t is going to be 1 by s square plus 1. Now we have to differentiate this by u by v rule. Minus denominator is s square plus 1 whole square v du s square plus 1. Differentiation of 1 is 0 minus 1 into differentiation of s square plus 1 is 2s. Finally, we have to replace s by s minus 1. Now, minus of minus 2s divided by s square plus 1 whole square. S should be replaced by s minus 1. So minus into minus plus, we get 2s divided by s square plus 1 whole square. We have to replace s by s minus 1 at the end. Replacing this, we get 2s minus 1 in the numerator. In the denominator, s minus 1 whole square plus 1 whole square. So we don't want to simplify further. We can stop here. Yeah, this is more than enough. Suppose you want to simplify further, you can write this as 2s minus 2 in the denominator s square minus 2s. We will get plus 1. Already there is 1. So 1 plus 1, 2. This is my final answer. So to get more confidence, I will do one more problem on this type. Find the Laplace transform of t into e power minus 3t into cos 2t. Since we have e power minus 3t, we have to use the first shifting theorem. L of e power minus at into f of t is L of f of t. S is replaced by s plus a at the end. Then differentiation of the transform L of t into f of t. Now let us do one by one. First we have to apply the first shifting theorem. S is replaced by s plus 3 since we have e power minus 3t. L of t into cos 2t. Now L of t into cos 2t we have to apply differentiation of the transform. So minus d by ds of L of cos 2t where s is replaced by s plus 3. Now we have to differentiate, therefore minus d by ds of L of cos 2t is going to be s by s square plus 2 square, that is 4. Finally s should be replaced by s plus 3. Now differentiating using u by v rule, denominator v square, that is s square plus 4 whole square, in the numerator v du s square plus 4, and differentiation of s is going to be 1 minus now u dv. I'll keep s. Differentiation of s square plus 4 is 2s. Finally we have to replace s by s plus 3 and we have a minus outside. So minus of s square plus 4 minus 2s square. Denominator we have s square plus 4 whole square. Here s should be replaced by s plus 3. Therefore we get minus of minus s square plus 4 divided by s square plus 4 whole square, where s is replaced by s plus 3. Now multiply the minus inside, we get s square minus 4. Finally replace s by s plus 3. So we get s plus 3 whole square minus 4 in the denominator, s plus 3 whole square plus 4 whole square. If you want to simplify further you can do, but this is more than enough. You can stop here. Hope you understand, students. So in this session we learned how to solve the problems when we have multiplication of t power n with f of t.
Thanks for watching. Hope you found this video helpful. Subscribe to our channel and share it to your friends. See you in the next video. Bye bye.